Hey everyone, and welcome. Today we're going to dive into the fascinating world of medications that keep the most important muscle in our bodies beating just right. We're talking about the drugs that literally restore your heart's rhythm. So let me just start with a question for you. Have you ever really stopped to think about what's behind that steady thump thump in your chest? I mean, what's the secret to keeping it in perfect time? Well, the answer is pretty incredible. It's actually a finely tuned electrical symphony. It's the super complex series of signals telling your heart muscle exactly when to squeeze and when to relax, all day, every single day. But, just like any orchestra, sometimes things can go wrong. A note gets missed, the tempo is off, and suddenly that beautiful, life-giving symphony goes completely out of tune. And that brings us to our first part here. We're going to talk about what happens when that rhythm gets all messed up. Let's look at what it means when the beat goes wrong. The official medical term for this is arrhythmia. Now, that sounds complicated, but it's really just a catch-all term for any kind of abnormal heart rhythm. This could mean your heart is beating way too fast, or maybe way too slow, or sometimes it's just beating in a totally chaotic, irregular pattern. And there are a ton of different kinds, but some of the ones you hear about most often are things like atrial fibrillation. That's where the top chambers of the heart just kind of quiver. Or ventricular tachycardia, a really dangerously fast rhythm in the bottom chambers. And also supraventricular tachycardia, which is a super fast heartbeat that starts about those lower chambers. Each one is a different way that electrical symphony can get disrupted. So if the rhythm is broken, the big question is, how do we fix it? And that's exactly what this next section is all about. We're shifting from the problem to the solution. We're going to focus on restoring the rhythm. I mean, think about the challenge here. How do you possibly correct a complex electrical system inside an organ that's constantly moving? How do you bring that harmony back? Well, allow me to introduce the conductors of our symphony. Anti-arrhythmic drugs. Yep, these are the special medications designed to step in, suppress those abnormal rhythms, and get the heart right back on track. But here's the thing, they don't all work the same way. Not even close. To really understand them, you gotta know the system they're organized into. It's a really neat four-class system. And to get a handle on how all these drugs work, you really only need to remember one number: 4. That's it. There are 4 main classes, and each one targets a very specific part of the heart's electrical cycle. And this table here, this is basically our roadmap for the rest of this explainer. It's super simple when you break it down. Class 1 goes after sodium channels, Class 2, beta receptors, Class 3 hits the potassium channels, and Class 4 targets the calcium channels. 4 classes, 4 different targets, 4 different jobs. Simple as that. All right, so with our map in hand, let's zoom in a little. We're going to go through each class one by one to see exactly how these different blockers get the job done. First up to bat, we've got Class 1, the sodium channel blockers. I want you to think of these drugs as gatekeepers. See, your heart cells have these tiny little doors on them called sodium channels. When they fly open, sodium rushes in, and that's what kicks off the electrical impulse. These drugs basically stand at the gate and tell that sodium to slow down. The end result? They slow down the electrical signals traveling through the heart muscle. Some of the key players in this class include drugs like disopyramide, quinidine, flecainidine, and propafenone. Okay, next up is a class of drugs I bet you've heard of before. Let's talk about Class 2, the beta blockers. I love this analogy. Think of beta blockers as noise-canceling headphones for your heart. You know when you get stressed or excited, your body pumps out adrenaline, which is like screaming at your heart to beat faster and harder. Well, beta blockers just put on those headphones, block out the noise from the adrenaline, and help bring the heart rate back down to a nice, calm level. And the examples here are super common medications. We're talking about atenolol, metoprolol, and propranolol. All right, let's keep it moving. On to our third category, Class 3, the potassium channel blockers. And we're back to our gatekeeper idea. This time, these drugs are standing guard at the potassium channels. By slowing down how fast potassium leaves the heart cells, they basically make the heart's electrical recharge phase a little longer. This really helps to stabilize the rhythm and cut down on those chaotic electrical impulses. And you've got some pretty powerful drugs in this class, including amiodarone, dronedarone, dofetilide, and sotalol. And that brings us to our final group, Class 4, the calcium channel blockers. Now, calcium is really interesting because it plays a huge role not just in the electrical signal, but also in how hard the heart muscle actually squeezes. So by blocking the calcium channels, these drugs get a two-for-one deal. They lower the heart rate, and they also reduce the force of the heart's contraction. Pretty cool.
The two main examples you need to know in this class are diltiazem and verapamil.
Phew! Okay, we've covered a ton of ground. 4 classes, 4 different ways of working. So let's just pull it all together and focus on the single most important thing to remember.
So here's the bottom line. If you remember one thing, make it this. It's all about being a blocker. Each class is just a different kind of blocker that targets a specific part of the problem. Class 1 slows the signal by blocking sodium. Class 2 blocks the influence of adrenaline. Class 3 cuts down on extra impulses by blocking potassium. And Class 4 reduces the rate and force by blocking calcium. It's a really elegant solution to a really complex problem.
And that kind of brings us to the end. But it also opens up a really fascinating question about the future, doesn't it? We've mapped out these 4 big electrical pathways, but the heart is just so incredibly complex. As we learn more and more about its electrical system, you have to wonder, what new, even more precise targets might we discover next to restore its rhythm? What's the next big thing going to be? Something to think about. Thanks so much for watching.